Okay, good morning to all. Our next topic is earth fault relay. So the relays which are used for protection of power system elements against earth faults are known as earth fault relays. So earth fault relays are used for protecting the power system equipments, okay, against the earth faults. Okay. So if earth fault occurs in any equipment in the power system, then these relays are used. So I'm just for example, I'm showing one type of earth fault relay here. It is a directional earth fault relay. Just to understand the concept, I am showing this image. If you see here, this can be an alternator winding or a transformer winding. Okay. So these are the three phases. To these phases, CT primary is given. Okay, these are the CTs connected to these three phases: phase A, phase B, and phase C. Okay, and the uh, currents in the secondaries of these CTs are IA, IB, and IC. Okay, if IA, IB, and IC are the currents in the secondaries of the CTs for these different phases, then the sum of these three currents, IA plus IB plus IC, you can see here it is written here. Okay, the sum of these three currents, IA plus IB plus IC, okay, is known as residual current. Okay, so let us give a notation for that. IRS, I suffix RS, I subscript RS is the notation for this residual current. Okay, so if IA, IB, and IC are the currents in the secondaries of the CTs of these different phases ABC, then the sum of these three currents is known as residual current. So you can see here in this image, IRS is the residual current. Okay. So an earth fault relay is energized by this current. Means this relay will operate due to this residual current. So under normal operating condition, this residual current will be equal to 0. Okay. So IRS is equal to 0 under normal operating condition. Okay. So IRS is equal to what? It is equal to 0. Okay, so whenever earth fault occurs, this IRS will no longer be equal to 0. So it is not equal to 0 if earth fault occurs. So whenever this IRS value, that is this residual current exceeds the pickup value, the earth fault relay will operate. So during balance load condition, earth fault relay will carry no current. Okay, under balance load condition, this earth fault relay will carry no current. Hence, theoretically, its current setting may be any value greater than 0. Okay, but in practice, it is not true. Okay, as ideal conditions do not exist in the system. Okay, so the manufacturers provide a range for earth fault relays 20% to 80% of the CD secondaries, rating in steps 10%. Okay, so the magnitude of earth limit current will depend on the fault impedance. Okay, the magnitude of the earth limit current will always depend on the fault impedance. In case of earth fault, so if earth fault occurs, then the fault impedance will depend on the system parameters. Okay, the fault impedance will depend on the system parameters and also on the type of the neutral earthing. Okay, so whether the neutral is solidly grounded or the neutral is grounded through a resistance or reactance. Okay, here in this image the neutral is not grounded. Okay, in this image I have not shown any means I didn't connect this neutral to the ground. Okay, so the neutral may be solidly grounded or it may be grounded through a resistance. reactance. So the fault impedance of the earth of the phase. I have changed the internet connection now. I think my voice, is it okay, my voice? Can anybody inform? Can you text me? Yes? Okay then. Okay. So let us discuss one type of earth fault relay, that is directional earth fault relay. Okay. I'm showing you the same image because just for example, I have taken this directional earth fault relay. Okay, so let us discuss about this directional earth fault relay. So for protection against this ground faults or earth faults, only one directional earth fault relay is more than sufficient for protecting any one equipment in the system. Okay, so its operating principle and construction will be similar to your directional overcurrent relay, which we have already discussed. So if you remember the directional overcurrent relay, so directional overcurrent relay, if you remember, it consists of an upper electromagnet and a lower electromagnet, and there will be a potential coil wounded in the central limb of upper electromagnet and a current coil wounded to the lower electromagnet. Okay, so the operating principle and construction of this earth fault relay is similar to your directional overcurrent relay. Okay, so this relay consists of two elements. One is directional element and another element, that is inverse definite minimum time element. Okay, this relay will be consisting, this directional earth fault relay will be consisting of two elements. One is directional element and another one is IDMT element. Okay, so the directional element has two coils, which you already know. Those two coils are what? One is the potential coil, another one is the current coil. Okay, potential coil and the current coil. Okay, it has two coils. One is the potential coil and another one is the current coil. Okay, so the current coil of the directional element is energized by the residual current. Okay, if this is the current coil, okay, of this relay, directional earth fault relay, this is, it is energized by this residual current, and the potential coil, okay, this is the potential coil, which is is energized by the residual voltage. Okay, so current coil is energized by the residual current and potential coil is energized by the residual voltage. This connection is suitable for the places where neutral point is not available, means when it is not grounded. Okay. Okay then. So So it is the same image. I was showing you something else. Okay. Now, so the residual current you already know, IRS is equal to IA plus IB plus IC. Similarly, the residual voltage is VA plus VB plus VC. Okay. So the directional earth fault relay will sense the direction in which the earth fault has occurred with respect to the relay location, and it operates for the fault in a particular direction. Okay. So this directional earth fault relay will sense the direction in which the earth fault has occurred. This relay will sense the direction in which the earth fault has occurred with respect to the relay location, and it operates for faults in a particular direction. Okay. So the residual current, that is IRS, is given to the current coil, and the VRS is given to the voltage coil. Hence, the torque that is induced, okay, hence the torque that is induced will be proportional to IRS into VRS into cos phi minus alpha. Okay. So where this phi is the angle between IRS and VRS, and alpha is the angle of the maximum torque. Okay. So alpha here, the alpha is the angle of the maximum torque, and phi is the angle between IRS and VRS. Okay. So if the neutral of an alternator or transformer is grounded, okay, so you can see here. So let us assume this is these windings are the either alternator windings or three-phase transformer windings. If its neutral is grounded, then this neutral point will be grounded through a potential transformer. Okay, this is a potential coil. Okay, voltage coil or potential coil, potential transformer. The voltage coil of the directional earth fault relay may be connected to the potential transformer. This is the potential transformer. I might have written here PT. Okay, I will write now. Okay. Okay, so this is a potential transformer. So the neutral point is grounded through a potential transformer, and the voltage coil of the directional earth fault relay may be connected to the secondary of this potential transformer. Okay, the IDMT element. Okay, so that is inverse definite minimum time element has a plug setting multiplier for this relay. The IDMT element has a plug setting multiplier value of 20% to 80%. Okay, so this is the operation of a directional overcurrent relay. Okay. So let us solve some problems. Let us solve some problems. All of you start writing. I will check your notes. So an IDMT overcurrent relay is used to protect a feeder through 500 by 1 ampere CT. Okay, so means the primary rating of CT is 500 and the secondary rating of CT is 1 ampere. Okay, the primary rating of the CT is 500 amperes and the secondary rating of CT is 1 ampere. The relay has plug setting of 125% and time multiplier setting of 0.3. Okay, find the time of operation of the relay if a fault current of 5000 amperes. Okay, if fault current of 5000 amperes flows through the feeder. Make use of this data that is given. Plug setting values are given with respect to the time for unity of time setting multiplier. Okay, so plug setting values are 2, 3, 5, 8 and 10 and 15. Their corresponding time for unity is for PSM of 2, the corresponding value of time for unity is 10. For PSM of 3, it is 6. For 5, 4.5, 8, 3.2, 10, 3 and 15, 2.5. This is the given problem. Okay, and you have to determine the time of operation of the relay if the fault current is 5000 amperes flowing through the feeder. Okay, note down the question. As soon as you complete, type C. Did you complete writing the question? Today I don't want to hear any excuses. All of you must write, then only you will get the attendance. Did you complete? Did you complete? Make it fast. Okay. So if you see here, the fault current of 5000 amperes is given. Okay. Fault current of 5000 amperes is given. Let us give a notation to this IF. So if IF is the fault current of 5000 amperes and CT ratio is what? 500 is to 1. So CT ratio is 500 is to 1. So the relay current is what? Fault current by CT ratio. Fault current is 5000 by CT ratio is 500 by 1. You will get 10 amperes. Complete this and inform me. Completed. Okay then. Now you know the relay current. Okay. How much is it? Fault current by CT ratio. That is 10 amperes. Now, pickup value of the relay is given by current setting into rated. Okay. Pickup value of the relay is current setting into rated secondary current of the CT. What is the current setting value? Okay, flux setting value, if you go to your question and if you see flux setting of 125% is given. So 125% means current setting value, that is 125 by 100. 125% means what? 125 by 100 into what is the CT secondary rating? Primary rating is 500, CT secondary rating is 1. Okay, primary rating of CT is 500 and secondary rating of CT is 1. So 120 by 500 is the current setting into 1 is the secondary rating of CT. So you will get 1.25 amperes. Okay, now flux setting multiplier value is what? Flux setting multiplier value, in order to calculate the flux setting multiplier value of the relay, the formula is fault current in the relay coil by pickup value of the relay. So what is the fault current in the relay IR value? Just now we have calculated, that is 10 amperes. And what is the pickup value of the relay? That is pickup value of relay is 1.25. So 10 by 1.25 you will get 8. Complete it and inform me. Completed, very good. Okay, so you have got a plug setting multiplier value of what? 8. Okay, go to the table, go to this table. Okay, some data that is given here. Since this plug setting multiplier value is what? 8. For 8, the time for unity is what? For 8, it is 3.2. So from the given data, note down this time value, that is for plug setting multiplier value of 8, time for unity is 3.2. You just note it down. So the time corresponding to plug setting multiplier of 8 from the given data is 3.2 seconds. Okay. So now let us calculate the actual operating time. So actual operating time is what? The time corresponding to the given plug setting multiplier is 3.2. That is 3.2 into time setting multiplier value. So in the problem, time setting multiplier TMS value is given, that is 0.3. Okay. In the problem, TMS value is given 0.3, and the time corresponding to the PSM value is 3.2. So 3.2 into 3.3, you will get 0.96 seconds. Okay, so the actual operating time of this relay is, in which the fault, okay, the actual operating time of this relay, which is protecting the system, okay, or a feeder, okay, it is protecting a feeder in which the fault current of 5000 amperes have occurred. Okay, so means the fault current of 5000 amperes is flowing, the feeder in which, okay, the relay which is connected to protect this feeder, the time of operation of that relay is 0.96 seconds. If you complete, inform me. There are chances for problems of this model to come in your exam. Completed? Okay. Okay. Next problem. Okay, a fault current of around 2000 amperes, okay, has occurred. Okay, so a fault has occurred in this line, if you see. Okay, so in this line fault has occurred, and this fault current is around 2000 amperes, you can see in this image. And there are two relays here to protect this line, that is relay 1 and relay 2. Okay, R1 and R2 are the relays. Okay, R1 and R2 are the relays which have to protect this system against the faults. Okay, so relay 1 is set on 100%, and relay 2 is set on 125%. Okay, relay 1 is set on 100%, and relay 2 is set on 200%. Okay, so means the current setting of the relay is relay 1 is 100%, and current setting of the relay 2 is 125%, and the CT ratio is given, that is 200:1. Means the primary current of CT is 200 amperes and secondary current of CT is 1 amperes. Okay, so you can see here 200:1, 200:1. These are the CTs. Okay, so for discrimination, the time gradient margin between the relays is 0.5 seconds. Okay, so the time gradient margin value is given, that is 0.5 seconds. Determine the time of operation of these two relays, relay 1 and relay 2, R1 and R2. Both the relays have the characteristics as shown in the table. Table is in the next slide. Okay, as the characteristics means TSM and time of unity. TSM characteristics are these two. Okay. The relay number 1 have time multiplier setting of 0.2. Okay, and you have to determine the TSM of relay 2. Okay, so you have to determine the time of operation of both the relays and TSM of relay 2. Okay, so complete this slide and inform me. Completed? Very good. Okay. Anybody else who didn't complete? Type NC. All of you have completed? Okay. Okay then. Write down this given data PSM and time of unity TMS value. Write down this given data. Okay. So in this problem, actually we have two relays, relay 1 R1 and relay 2 R2. Now let us consider relay 1. Okay. And relay current, let us determine the relay current IR1. So IR1 is what? Fault current by CT ratio. Okay. So CT ratio above this relay 1 is a 200 by 1. Okay. So of course CT ratio for both the relays is same here. So what is the fault current here? Fault current in this line is 2000 amperes. So 2000 by CT ratio is what? 200 by 1. So IF by CT ratio is 2000 by 200 by 1. You will get 10 amperes. Okay. And pickup current is current setting into rated secondary current of the CT. What is the current setting of this relay 1? That is 100%. Okay. Current setting of relay 1 is 100%. Therefore, 100 by 100 into what is the secondary current of your CT, that is 1 ampere. So 100 by 100 into 1, you will get 1 ampere. So pickup current is 1 ampere. As soon as you complete, inform me. Completed? Very good. Okay then. Now plug setting multiplier value is what? Fault current in the relay coil by pickup value of the relay. So what is the fault current here? Fault current is what? Fault current is 2000, fault current is the relay coil, that is IR1. Okay, that is 10 amperes. Okay, and the pickup value of the relay is what? 1 ampere. So 10 by 1. Okay, so fault current in the relay coil 1, actually I must write here 1. I have not written. Okay, relay coil 1. Okay, that is relay 1. Okay, so fault current in the relay 1 is 10 and pickup value of the relay is 1. So you will get 10 by 1, that is 10. PSM value you have got as 10. Now, PSM is 10. What is the corresponding time? Okay, PSM is 10. What is the corresponding time? Go to the given data. Go to the given data. PSM is 10. Corresponding time is what? 2.8 seconds. Okay, so when PSM is 10, corresponding time is 2.8 seconds. Therefore, write down the time of operation of relay 1 corresponding to PSM of 10 from the given data is 2.8 seconds. So what is the actual operating time of relay 1 for TSM of 0.2? Okay. For TSM of 0.2, time multiplier setting of 0.2, in the problem they have mentioned it. Okay. So time multiplier setting value is 0.2. Okay. Time multiplier setting value is 0.2. So 0.2 time multiplier setting value, you have to determine the actual operating time of relay 1. So for 0.2, what is the time of operation for the given PSM? Is 2.8. So 2.8 into 0.2, you will get 0.56 seconds. Complete it and inform me. Okay, completed. Okay then. Next is relay 2. So relay current of relay 2 is what? Fault current by CT ratio. What is the fault current? Fault current same for both the relays. In the same line fault has occurred. Okay, so fault current is 2000. CT ratio for relay 2 is what? 200 by 1. So what is it? 2000 by 200 by 1, you will get 10 amperes. Pickup current is what? Current setting of relay 2 into current rated current of your CT. Current setting of relay 2 is what? 125%. 125% means 120 by 100, 125 by 100 into what is the secondary current of your CT, that is 1 ampere. Okay, secondary current of CT is 1 ampere. So 125 by 125 by 100 into 1, you will get 1.25 amperes. Next, plug setting multiplier value is fault current in relay 2. Okay, fault current in relay 2, that is IR2 by pickup value of the relay. So fault current in relay 2 is what? 10 amperes by pickup value is what? 1.25. You will get 8. PSM as 8. For this PSM, check the time value from the given data. If you complete, inform me. Did you complete? Okay then. Okay, so from the given data, what is it? For 8, it is 3 point. For 8, PSM 8, it is 3.15. Okay, for 8, it is 3.15. Therefore, you just write down the time of operation of relay 2 corresponding to PSM of 8 is 3.15 seconds. Okay, so the actual operating time of relay 2 is what? Time of operation of relay 1 plus time grade margin. Okay, so actual operation of the relay 2 is time of operation of relay 1 plus time grade margin. So time grade margin is given in the problem. Okay, time grade margin is given, that is 0.5 seconds. Okay, so if you observe here in this system, there are two relays R1 and R2. R1 is nearer to this fault, so the relay 1 must initially the relay 1 must operate with some time grade. Okay, with some time displacement, relay 2 should operate. So the time displacement given for this relay 2 to operate is 0.5 seconds. Okay, so this okay, if this relay R1 fails to operate, then only relay R2 will operate. Okay, so the time taken for relay R2 to operate is time of operation of relay 1 plus time grade margin. So time of operation of relay 1 is what? 0.56, which you have already calculated, plus 0.5. Okay, it is 1.06. Okay, so time of operation of relay 2 is 1.06. Okay, so if you see here in this image, if fault occurs in the zone where R2 is there, okay, R relay 2 is there, if fault has occurred here, then R2 will operate first, and with some time gradient margin, R1 will operate. So this time gradient margin is already set in the relays. Okay, so depending on the location of the fault, whichever relay is nearer to that fault, that particular relay will operate. If that relay fails to operate, then with some time gradient margin, another relay at some other location will operate. Okay, so time of operation of this relay 2 is time of operation of relay 1 plus time gradient margin, that is 1.06. So time setting multiplier value they have asked you to determine. So actual time of operation by time of operation corresponding to PSM. So actual time of operation of relay 2 is what? Okay, they have asked for relay 2. So time of operation, actual time of operation of relay 2 is what? 1.06 by time of operation corresponding to PSM is what? 3.15. Okay, so 1.06 by 3.15, you will get 0.3365. Okay, complete this. As soon as you complete, inform me.